Calculus came from the word little pebble. The term was coined since pebbles are used in addition during the ancient times, and calculus is based on summation of infinitesimal or extremely small differences. When we are talking about calculus, we are analyzing small parts of a whole. For example, if you are doing differential calculus, to find the slope of a point, we use the derivative of y with respect to x, right? Because we are taking the analyzing the small changes in that small change of distance. Small changes ng y, small changes ng x. Kaya nga pag when we say differential, meaning that is a small part of a whole. In a sense, also, in integral calculus, we are also analyzing using small parts or infinitesimal differences. If you are going to take the integral or the area between two curves, then we will be utilizing a small area indicated by the difference of y, for example, multiplied by the differential of x, or the difference in x multiplied by the differential of y. So, pag calculus ang pinag-uusapan, we are tackling about small objects. We are analyzing in infinitesimal differences. It was developed independently by Sir Isaac Newton and Gottfried Wilhelm Leibniz. So, here is my friend Isaac Newton and Sir Gottfried Leibniz. While working on motion problems towards the end of the 17th century. Calculus has two parts, differential calculus and integral calculus. Differential deals with the analysis of changes in infinitesimal parts of a whole, and integral calculus deals with adding infinitesimal parts to form a whole. So, pag differential calculus, we are dissecting the whole and we are taking small parts. If integral calculus, we are taking these small parts of a whole and then we are adding them up together to form the certain whole in the case of an area or a volume. So, derivatives and integrals. Derivatives of functions can be geometrically interpreted as the slope of a curve of the mathematical function f of x plotted as a function of x. So we have here your curve defined by the function f of x, and if you are curious about the slope of that specific curve in that specific point at x is equal to a, we are going to find the derivative of y with respect to x at that specific point. In this case, x is equal to a. The derivative of the function is evaluated at x is equal to a. And by that, we already have your slope of the curve. So that is the geometrical use of the derivatives of functions. But how can we use them in physical quantities? Take note that we can use this when we are looking for the velocity or acceleration of the motion of a certain object. Velocity is defined as the change in the speed considering the direction of that specific object in motion. So for example, yung velocity natin, that is just equal to the change in position with respect to time. And similarly, your acceleration is the change in velocity with respect to time. So those are the use of derivatives in your physical quantities. Not just geometrically, but we can also use it in physical analysis of these problems. Next would be the integrals of functions. Integrals of functions can be geometrically interpreted as the area under a curve of the mathematical function f of x plotted as a function of x. So the same curve, if you are looking for the area bounded by the curve, the x-axis, the boundary conditions, or the boundary x is equal to a and x is equal to b, we can now look for the area using the integral of the function of x multiplied by the differential of x from a to be. So, alam nyo na yan, that is integral calculus. But what are the physical quantities that we can use this? For physical quantities, we can use integral calculus for analysis of areas and centers of mass. We can also use this for looking the moment of inertia of certain objects. So those are derivatives and integrals. Basically a review of your differential and integral